Hi. As promised, this is the last lecture on the ICT 3102, and it will be primarily regarding the assignment. Thank you all for submitting the assignment, and I really enjoyed the walking through and running through all the stuff that you guys brought in. Thank you also for the videos. Some general feedback though. The way that I considered the assignment is based on two. So firstly, we have the functional considerations and the performance one. So as always, every time before we talk about performance, we always have to make sure that functionally it works well. And why? As we mentioned many times before, we always want to make sure that we are optimizing the right thing. We don't want to be optimizing a piece of code that is not working correctly. In an example, it's like if let's say you are sawing a branch, or rather sawing a tree, and the saw is blunt. It doesn't make sense to find the best way to saw it well. What you should be doing is actually to sharpen the saw instead of trying to find the best way to saw the branch. So that is also the same concept that I like to have, whereby we always make sure that it is working properly first, and then thereafter to consider about whatever performance that we can improve upon it. So we first make it work, make it right, and finally make it fast. So for this assignment, we consider two factors. So the first one is that of the creation of the API from the YOLO interface. The YOLO interface currently already has the JSON format, and then we also have to create that of a single page application, and we dockerize them properly, and then there is 5% bonus, or rather 5% that's devoted to load balancing or whatever creative items that you have. Notice that the scoring scheme here is very different. Even if you do, meaning that the out of 20 points, 15 points are, or rather the framework of how you score the 15 points are provided. So meaning that if you do everything by the book, you are at most going to get 15 out of 20. So the whole intention of the entire assignment is to really force the teams to go outside of the box, to see what are the other things that you can include in order to make it even better. And I have intentionally made it in this way so that it is to hopefully encourage the teams or encourage the individuals to really think through, rather than what, of course, delivering according to the requirements is extremely important, but then there's also a flip side to it as to what are the things above and beyond the requirements provided to you that you can improve or you can do in order to make whatever product that you are creating better. So that is the main intention of this portion of this assignment. And how we assess it is in the following. So again, I mentioned there are 4 things, and then there are 2 considerations. So we have a sort of a metric scheme whereby we consider first for every individual portion whether may or may not does it fit the functional considerations, and does it or does it have not fit whatever performance considerations that we have there. So these are just some of the very common things that I normally watch out for, like for example, if the page is buggy or not, or if the containers are correctly dockerized, am I able to run the containers easily. Some of the performance consideration from the API maybe things like how are the results returned, do they give the impression at least of the fast load, and are they able to scale properly or not. So these are just some of the metrics that I use. They are not really exhaustive, but they are, I think generally that should be one of the things that these should be some of the things that you should watch out for. And in general, all the teams had a few minor issues. Once again, these are very, very minor. You don't really lose points because of these, but they are just things that are a little bit that you should take care of. So for example, if you have a blank image, or if the image has no objects, does it properly tell you that? if I'm able to shut down all the containers and there are no services that are available, does it tell me that the service is unavailable? Meaning that in general, does it fail gracefully or not? So you guys are going into IWSP very, very soon, and I think one of the things that is different between academia and industry is the following. In industry, we always, or rather in academia first, in academia, we always talk about very strange conditions. We want to talk about how certain algorithms may be able to run properly for every single thing. But sometimes industry, we don't consider those things. Whereas we consider things like what are the common cases that always occur. And we try to make sure that those cases, they can run really, really well and they run really, really fast. You want to cater the product for as big a group as people as possible, and we want to make that group of people as happy as possible. Of course, there are odd cases that come about, and for those odd cases, we might not we might not be as concerned over the performance as what the academia may be concerned about. We just need to make sure that it doesn't die, it can run a bit slower, and if it fails gracefully. So those are some of the things that, at least for me, in the past when I transited first from academia to industry, that was one of the things that was very, very different. Meaning that we just want to make sure that it works, firstly. As I said earlier, to make it work first, then to make it work correctly, and then finally to make it work fast. And even for fast, there is a certain priority to what we make fast too. So I believe when you go on to your IWSP and to your various so-called various workplaces, you'll discover this more and more. And so I go on to the team, the different teams. The interesting thing about this is that very nice touch. This 5% whereby no framework or no criteria of judging is provided. It gives you, or rather, it gives every single team the ability to think out of the box. And I'm actually very happy that every team, or almost every team, took it and expanded on it with a very, very different angle. So I don't see that much commonality among different teams. So there is a lot of diversity here. And the good part is that it means that there is a huge potential for us to be able to learn from one another. So yeah, without further ado, right, let us go on to see the first team first. But before that, I think it will be a good time for me to stop the recording in case something screws up. So we'll first start with team 1. As you can see, team 1, they really did things that were really, really different. So for example, they did Kubernetes in order to store the various YOLO containers. They did Convars for the rendering of the images. They also did image caching in order to make certain things a bit faster. So the only regret that I had was I had a bit of issues with the installation of the Kubernetes, but other than that, I think they did a really, really good job in what they do. Please to look at the video, and I believe you really enjoy what they have done. They have their service available online for paustechnology.club. They must love dogs. So yeah, so do try out, and I think you'll be pleasantly surprised. I'll run through the various teams first, and I will leave the team presentations right at the end, and you probably can just yeah, you highly encouraged to watch through all of them. I think all of them have their so-called there are good points that all of us can learn from. Team number 2. Team number 2. Okay, so team number 2 was really great. So firstly it did the Spring Boot under they did the Eureka Service Discovery. They did the Zoom. So it was really, really nice experience that I had when running their Docker containers. Yeah, extremely good user experience. There were a bit of strange color issues, but that is very minor. Overall, it feels really nicely done. I deleted one of the YOLO containers, and the load balancing really works really well. I think it could so-called respawn that container again. A bit of issue with trying to scale the containers more than 3. They cited numbering issues for the port. I think there was some there probably was some configuration issues on that part. It is very minor, but if that part was made well, I think yeah, it's a pretty nice, well done project that I have to admit, it's a really well done project. Team number 3. So they did a variety of how to say, a variety of features as well. So single point entry using Spring Boot, progressive image loading. Some of the teams asked what progressive image loading is. So progressive image loading is when parts of the, or rather the image is loaded how to say, at a lower resolution first, and then by and by the resolution gets a bit higher. So they do it to decrease the time of first paint. The time of first paint is when the user first sees something on your screen, and generally you want to reduce that because it gives you the impression that the page does load a lot faster. Some of the other things that they did was the client-side load balancing using the Netflix ribbon. Again, the unfortunate thing with Team 3 was that I had some issues with the YOLO installation. Yeah, so that was the one of the the disappointments that I had. I really did want to play around with that, but I unfortunately couldn't have the chance to. But we'll move on to the next team, team number 4. I had a great experience with Docker, with them. They use Docker Swarm. Really good experience. The nice thing about this team is that they had this control panel thing at the side, where from the objects that returned, you could excuse me, you could click into the various objects that were returned, and for those they highlighted which was the object that was being returned. I thought that was a really nice touch. There was a bit of image scanning issues. There were many unnecessary clicks that had to be done. Just in general, when you're designing UIs or what, you know, people literally count the number of clicks that you need to get from one end to the other. So in general, you want to reduce as many number of clicks as you possibly can. Doing Dockerization was fine, but the loading of weights was a bit slow. I don't know why, but it's fine. Deleted one of the YOLO containers and it works. Yeah, for this, what happened was that they had 2 versions. One version without the swarm, the other version with the swarm. The one with the swarm was deployed on RD Cloud. I unfortunately could not really test or use that as well, so that was a bit of a disappointment. But we'll come to a team later on that uses a swarm that I could test on my local machine, and I had a really nice experience with that. We will talk about that a bit later. Team 5, they did work cloud. It's a bit so the project was okay. They had some minor issues here and there, but generally it worked well and everything. One thing I wanted to point out in here was that they needed to do a lot of rollback when I had to reinstall it. So this is one thing that you might want to take note of. So meaning that if in the future, if you needed to roll back a lot of things when you are doing any reinstallation, you may want to include these in your somehow in your Docker Compose file, that to remove, I'm not sure whether it's possible, I believe it is, to remove certain containers before it can be run again. I'm not sure whether it's possible, but I got a feeling that it should be, but I'll check that later. Yeah, so yeah, but generally it was fine. Minor thing about this, the word cloud is a very nice touch. Just a few comments on that is that it would be a lot better if they would so how to say, they would they will group up certain elements together. So for example, you may have an image with 5 people inside, and what happens is that it comes out as 5 people words in the word cloud. So might not be as useful as if we were to combine these people together using maybe their confidence levels or something of that sort to make it more representative of what the image is trying to say. But nonetheless, it is a nice touch. When I tried to kill off one of the containers, it was slow initially, but then it recovered really well. So go on to team 6. I'm okay. I will try not to, but I'm very impressed with team 6. I'm actually very impressed with team 6. The elements they use were very simple, very simple stuff. So they used but extremely effective. Many small touches, but all in all, it turned out to be a really effective project. So for example, they passed the image data as binary in order not to store any access data on the server. Very nice touch. I believe they spent a lot of effort to get it to work. They use GraphQL, but another nice touch. They use dependency checkers to cut down on the Docker image. They also use Docker Swarm as well for their deployment. I could run this Docker Swarm on my local machine, and I was very pleasantly surprised by it. And containers, the redundancy was there, and the so-called they could auto respawn whenever I killed off certain containers. So it worked well. It really worked very well. Yeah, so I'm very happy and very impressed with that. They had a very small a very small you can call it API endpoint, where it allowed me to check that the load balancer was working properly or not. The reference to that is at the bottom. They use HA proxy in order to carry out the load balancing. The article that is there on the bottom of the page, I think that's a great resource. I may even use it in my next trimester when I'm teaching your juniors. So I think I highly encourage you guys to look at it. I think this team did really well. I'm very happy with them. Team number 7, it's a persistent team that fought to the last minute. So there were some minor issues here and there, but generally it worked well. The load balancer works at the end as well. So so a bit of laggy here and there, but in general, it was still pretty okay. So I go on to team number 8. Oh, team 8 is I was pleasantly surprised when I first saw team 8. So what they did was that they had a lot of redundancy, not only at the front end and also at the back end. It was really nice. So what happened was that apparently what happened was that when I dug in a bit deeper, they mentioned that somehow the front end kept on crashing. So because of that, they had a redundancy and then on the front end as well. I mean, I thought it was very funny, but it was great. I mean, it worked well. So apparently even at the demo, the front end crashed, and we didn't know about it because of the redundancy that was working. So it was a very strange way to solve an inherent bug, but at least they managed to pull it off. Whatever way they did it. The unfortunate thing is the load balancer at the backend didn't really work very well. So although I killed off some of the services there, it still it continued. It ran very slowly. So I think it was still trying to communicate with the how to say, with the containers that were dead. So that was the really unfortunate part on this for this team. But other than that, I like the way they did the app. I like the way they organized the containers. So well done. Team 9 was also another persistent team that fought to the last minute. So as what one of the members actually told us was that they did a lot of learning along the way, and I really commend them for that. So in fact, during the presentation, it wasn't as optimized as it was at the end. So yeah, so they really fought to the last minute and use whatever time that they have to to containerize as best as possible. Yeah, so I think it'd be good to learn from one another, and yeah, so yeah, I'll go on to the last team. So team number 10, that actually, for team 10, it was interesting in the sense by the architecture was very simple and nothing very fanciful, but the whole thing worked very smoothly. So when I dug in a bit deeper, one of the members mentioned that they tuned a lot of the Nginx server, and I that might be one of the big reasons why the entire operation was so smooth. And I asked for some permission on how they tune the Nginx server, and very kindly, I think the gentleman's name is Jing Hao, because it's Jing Hao, 很好. So yeah, so he shared with us how he tuned the server. So I have taken the next few slides on how he did the server-side caching, no, the server-side optimization of the Nginx server. So yeah, so these are all the 10 teams that are for you. Right now I will be playing the videos from all the 10 teams back to back. At the very end, I'll come back again for minor roundup of the entire course. Thank you.
The single-page application allows users to drag and drop a file or click on Browse to upload a picture. And then we click on Upload. There's a notification that the file has been uploaded and the image is shown below. The color of the boxes are determined by the accuracy. Now we're gonna try to upload a picture with more objects to see how it looks like. In cases where objects are overlapping each other, you can just hover over the text to see the object beneath. Now let's try uploading the same picture that we uploaded before, which was the bird orange. We can see that the image loaded very fast because there was cache. We'll try it again with the same photo that we uploaded before, which was the small dogs. And it instantly shows. The team aims to be able to achieve long-term scalability, maintainability, and usability for the final product of this project. From the table, we can see that React.js is generally faster than the other two frameworks. It is of advantage to us that the main feature of the app is to draw a bounding box over an object, and it has faster rendering and painting speed. The system architecture includes the client and server that communicates via RESTful APIs. The main idea of the design is to create a microservice architecture where the services are independent and also portable. We know that Docker allows spinning up multiple containers to suit demand workload, but using it alone isn't sufficient. Problems such as handling of failed containers and managing containers will arise, and that's where Kubernetes comes in handy. The worker nodes that contains multiple pods can be configured to scale automatically according to the different server workload. Pods are used as a single unit of replication in Kubernetes, and how each pod is scripted for deployment plays a role as it affects how the resources in each pod is consumed. The process of creating new worker nodes is automatically handled by Kubernetes. That is one of the key reasons for choosing this technology. Load balancing will also be automatically handled, which offloads a lot of performance issues. This helps us achieve the goal of developing an app with high scalability. The sequence diagram illustrates the idea of isolating the image detection algorithm from the client so that there is a clean separation of concerns. One of the main highlights is how step 1A and 1B are performed asynchronously in the client side. Drawing of the image uploaded by the user, although not having its object recognized yet, will be done asynchronously together with the sending of requests to the server side. Another point to highlight is how a cache lookup is performed after a request has been received by the object detection service. This lookup aims to minimize the need for performing an object detection should the image be repeated.
Hi everyone, in this video we'll be covering Team 2's 3102 second project. In this video, we'll be covering the architecture design selected by the team, the different types of services created, what each service does, as well as how they work together. First up, we'll be talking about the architecture. The microservice architecture breaks the traditional monolithic application into small individually packaged services, each with its own responsibility. These individual services can be deployed into containers and can be scaled individually by spinning up more instances. This allows for horizontal scaling. The application has been broken down into four main services: the front-end web service, service discovery service, gateway service, and object detection service. The front-end service is a web server that serves the front-end to the user. The server is written in Vue.js. The service discovery service is called Eureka and is developed by Netflix. As the name implies, it discovers services the system requires and stores them in a registry, something like a phone book. In this case, it would include the gateway service and the YOLO services. Eureka is REST-based and provides multiple endpoints for other services to register and deregister themselves to. Registered services are required to periodically send heartbeats to the Eureka server. This means periodically calling one of the Eureka server's endpoints. The Eureka server also periodically checks if all services have sent a heartbeat to it. If a service fails to send a heartbeat to the Eureka server for more than a configurable amount of time, the Eureka server removes the service from the registry. Another important functionality the Eureka service provides is an endpoint that can be called to fetch the existing registry, and a list of IP addresses of servers that provide those services. This can be configured with multiple Eureka servers to extend the service discovery abilities. Two Eureka servers can share registries with each other. However, for this project, there is only one Eureka server as a proof of concept. The gateway service is called Zoo and is also developed by Netflix. The gateway service provides the ability to dynamically route requests from the requester to a service. On boot, the Zoo server requests the service registry from the Eureka server and continues to do this periodically. The Zoo service is configured to extend multiple endpoints, each tied to a service, such as Assassin localhost port 8762/YOLO/endpoint will cause Zoo to route the request to the YOLO service. When a request is received, the Zoo evaluates the endpoint, identifies the service and picks one of the available servers to send the request to. The returned request is then forwarded back to the requester. For the Spring Cloud implementation of Zool, each request passes through a filter chain, which is essentially multiple layers that can intercept and modify a request. This can be extended to provide security features such as authentication and authorization, as well as static response handling. Static response handling is important as it provides a static response at the edge instead of forwarding the request to the internal cluster. This can be used to return cached requests so that the requests do not actually have to reach the internal YOLO services. There will only be one Zool server for this project as a proof of concept. A REST endpoint has been added to the original YOLO script so that the script's functionalities are accessible from the outside. The library used for the REST API is the Python Flask library. The loading of the model options and models have been placed at the start of the script, before the REST server is brought up. This is to load the models first, as the loading of models takes the longest, and it is best to only have to load it once. After it has been loaded, all calls can directly use the loaded model without having to wait for it. The next section will cover the overview. Here we have our Eureka server, Zool server, and YOLO services. Each YOLO service and Zool server registers with the Eureka service, and the Zool server gets the registry from the Eureka server. These can be seen by the purple lines. Next, we have our Vue.js web server. The web server is in charge of delivering the single-page application to the clients that request for it. The green arrows depict the requests and response for the single-page application. From each client, every time a user uploads an image to the client and clicks on the submit button, a request is sent to the Zool server. The Zool server can check if the request for a certain picture has been sent before. If it has, the Zool server returns a cached copy of the previous response. If not, the Zool server then identifies the service that is requested, routes the request in a round-robin fashion to one of the YOLO services. The response from the YOLO service is cached and then forwarded back to the server. This can be seen from the black lines. That's all for Team 02's Project 2. Thanks for watching.
I'll be presenting the front end to you guys, and we have used Angular as the front end for our SPA. So firstly, I'll demonstrate the browse. I'll demonstrate how to upload a file. So the team has done multiple upload as well, but firstly we want to show the singular upload. So firstly we go to network. Yep. And when you upload, you will send a request to the YOLO service, and while waiting for the service there is a loading bar. Because it takes a while to load the image. As you can see from the image just now, there is a blur effect. This is to signify that it is a progressive image upload. So how we did the progressive image upload is by using an API called NGX Progressive Image Loader. So this API provides us a way to blur out the image first if you have weak data connection, and it will show if there is no internet, it will show a thumbnail, else it will show the base64 image. Yep. So next would be the multiple upload. So next I'll show the multiple upload. So as you can see, these are the files that I tries to upload, and what we have done here is for each file we generate a request to the server. So as you can see, there is multiple requests to the server. So while it is loading, I'll show you how I implement text doc into this file upload. Because there is a shared resource being used, so we would not want to have a race condition in the web application. So this upload list is a shared resource. So in this shared resource, we have used we have generated a request to the endpoint, and when it returns, it raises for a condition where each instance will want to raise to push the element into the array. So what I've done here is to implement a mutex log so that each response would try to acquire the mutex log. Then once it acquires the mutex log, you state that the mutex log is false. Then you proceed with the critical section, and then it releases to the log. Yep. And here it is. Here is the finished result of the SPA. Yep. And one more thing is that we did a list of identified objects for the SPA, and that's it.
So what I'll be talking about next will be the backend server for our application. On the right hand side, you can see over here, this is the registry or the service discovery part of our application. This is built upon Spring, so you just need to import in the appropriate dependencies and have the correct annotations in the main class. For configuration wise, you just need to specify a application name and a server port. Typically for Eureka server or registries, the port will be 8761. Follow up. This is our gateway application, or the one that is actually interfacing with the client, with the front-end client. This particular REST API endpoint, multi-YOLO, is the one that is being called for the requests, for multiple requests. So within this API endpoint, we can actually custom set our own responses, and we can send that over in JSON format. Moving on, as the application is built upon layers and layers for maintainability and actually being able to code in a very systematic structure. Over here, you can see over here is our recognize image method class. Within this method class, we are actually firing off a HTTP post request to the YOLO service. But notice that it's not being called using an IP address or anything like that. It's being called using a service ID, upon which it will automatically resolve when it's communicating with the registry. Next will be the configuration for this particular gateway class. As you can see over here, the configuration for the gateway class, all that's needed is the client service URL default zone, which points to the registry, and it will automatically, and because the dependencies for the Eureka client will automatically configure it. At this point of time, because we're using Docker, we can just input the service ID and it will automatically be routed accordingly. Next will be the Zool proxy, upon which we can specify the routes that will automatically route the user or the request according to the appropriate service based on the service ID, or as you can see over here. Now, moving on to the Docker Compose. For the Docker Compose, is relatively straightforward. We are building the registry first on port 8761. The gateway and the YOLO services are dependent on this particular registry in order to be able to discover each other. As you can see over here for YOLO, there are 3 different ports set for it: 8080 all the way to 8082. These range of ports indicate that there can be up to 3 instances of YOLO, and they will be all on these 3 ports, which is 8080, 8081, 8082. This has to be specified on how many instances you want during the Docker Compose command. Next, we'll be talking about the REST API that holds the YOLO image recognition service.
We are using Python Flask as a web service API to handle the image processing request. The images are stored locally in the service. Then, you will call the YOLO function to process it. The image processing uses a trained model to help identify the objects found in the image, and based on the results, it will be returned as a JSON result.
And I'm Nazar.
Today we'll be going through our application for our 3102 YOLO. So let's first off take a look at how our Docker system architecture is being done. So all of our Angular and load balancing and YOLO backend is actually being hosted on Nginx, which is on Docker itself. So whenever a client does a request on Angular, which is the client, it will be handed over to the Nginx load balancer, which is then going to the YOLO backend application.
So basically what happens is that whenever there's a request, Nginx load balancer will check which service has the number of least connections, and then it would forward that specific request to. So all these containers and services are hosted in a Docker environment, so it's Dockerized.
Moving on, let's take a look at our Docker file and Nginx configuration.
Okay, so basically initially we have this 3102 YOLO service Docker file. So what happens here is all the dependencies and the Python requirements are all initialized here. So to speed it up our process, what we initially did was to get all these requirements ready, and we push it to Docker Hub as it's indicated here. So once this image is hosted in Docker Hub, all we have to do now is run this Docker file where we pull the Docker image instance, and then we just copy over our YOLO Python file over to the project folder, and we do a flash run. So doing this, we will save time on installing all the necessary requirements, and all we have to do now is just download that image and simply run. So as you can look into the Docker Compose file, we have two services. One is YOLO and YOLO 2 service. So both these services will be initialized at the start of the Docker Compose, and then there is also a Nginx service, and our front-end Angular client will be hosted in Nginx. So this is the Nginx configuration file. As you can see, we have a upstream backend where Nginx will load balance based on the number of least connections on either YOLO or YOLO 2 service. So all the incoming requests where there is /API will be forwarded to the upstream backend server. So now let's take a look at how our Docker Compose works. Okay, so now let's Docker Compose up and see what happens. Okay, so now the YOLO REST service and the Nginx services have all started successfully. So to check whether our load balancing is working correctly, let's bash into each of the YOLO service. And YOLO service 2. Okay, so when images are sent to the service, it will be saved in this folder called /images. Just currently in YOLO service 1 and YOLO service 2. So what we're going to do here is we're going to open 2 instances of YOLO service, and this is to ensure that the load balancing is done correctly. So for the first service, we would select 3 images. And let's select another 3 images for the other instance. So let's try to click upload as quickly as possible to see if the load balancing is done correctly. So as you can see, we get reply from both the services. So now let's go back to the service and check if all the images are split into 2 requests. So in the first service, there are 3 images, and in the second service, there's another 3 images. So this shows that our load balancing is done correctly, as request 1 is forwarded to YOLO service 1 and request 2 is forwarded to YOLO service 2. So now we will go through the features of the YOLO web client.
Alright, so as you can see on the left, there's a word cloud. So the purpose of the word cloud is actually displays the confidence level as sizes within the cloud. So if we go here, we can see a person. If we go to the second image, we can see a bunch of cars. Then based on the confidence level, it's being reflected on the cloud. Other than that, the user is also able to export the image. For example, I have this picture of NYC and export it. I can just save accordingly as an image. And yeah, pretty much that's all our app does. Thank you.
Hi, welcome to Team 6 Object Detection Program. The following system architecture diagram will give a high-level view of how the four main components interact with one another. First component will be the client-facing front-end running on React.js with GraphQL Apollo client, which then goes over to backend server transaction optimizing backend server running on Node.js Express with GraphQL Apollo server. There's a load balancing HA proxy over here with Docker Swarm to redirect the traffic to one of the replication of the YOLO servers. And finally, the YOLO servers that does the image object detection running on Python Flask. So a high-level view of the application single transaction is as follows. So client will submit an image on frontend with the stated minimum confidence level, which then backend receives the image, optimizes the request over to HA proxy that uses the least connection method to select which YOLO server to send the request to, after which the server comes back to HA proxy, which then goes back to backend server, and backend server actually optimizes the response and then passes it over through GraphQL to frontend, and frontend will receive the JSON response and draw on the image to identify the objects. So a few key selling point of the project is as follow. So one of it is the 3-layer architecture that we have built upon. So we separate very clearly the front end, the back end, and the YOLO server, because we realize that the image processing is mostly heavy loaded on the YOLO server, and once it's separated, we can easily scale by adding more powerful GPUs or adding more servers. Next, we will have the asynchronous client-side rendering, which is the client side will actually straight away draw the image first, and after it receives the response asynchronously, and it will draw on the image after which. Next, we have bytes array transmission over image. So in our system, no image is stored at all, and all transactions are actually based on a bytes array that is passed on from the servers to the YOLO server back to the client, and which is why we have actually considered about the storage space that is needed if you were to store the image, and realized that in this project there is no need for us to store the image, and we pass the images through bytes array. We also use GraphQL query and mutation, which is able to filter out the response accordingly to what the client would want. And this is actually in preparation of a scalable project whereby there might be more fields being responded in the future, and GraphQL will be very easily able to just filter that out. Next, we also follow a very user-centric design where we allow the users to set their minimum confidence level. So as you can see later on, all the low confidence level will be filtered out, and if the client were to put like a confidence level of minimum 0.75, this actually reduces the load on the server as well, because if the user does not want to see the low confidence level while we do it. Next, we also did a compressed Docker deployment. So initially, the Docker image is actually quite big, as you can see here. And after the compressed Docker deployment, we reduced the size by a significant amount, and it also helps to improve the time it takes to deploy the containers. Finally, we have a HA proxy load balancing, whereby we create replications of the YOLO server, and then as you can see here, there's actually 5 replications of YOLO server, and we do a test later on to show you as well that the containers are actually separate containers. So let's jump right into how we start this thing. So let me just start off with the CD YOLO. So just ignore the rest. I was cleaning up the images before we start the demonstration. So let's go into YOLO. I actually built the image beforehand, so we do not waste time waiting for the YOLO image. So we start the swarm by doing swarm init, and after which we deploy the Docker Compose file that is located at the YOLO server folder. So we are basically creating the network for the Docker Swarm and creating the services. So later on, they will know what are the replicated servers that's needed, and we can actually update here to start the containers. So actually inside the Docker Compose, Compose file, right, we have stated 5 replication as a default. So when you're running this, they will actually run 5 Docker containers. You can see that there's 5 YOLO containers right now, and then the HA proxy to control everything. So we will just go back to the main root folder, and we do a Docker Compose up to run our front end and our server. So while this is running, I'll just explain how we do the detection of the load balancing of the YOLO servers. So as you can see, in our Flask API, we actually have this test load balancer API here that fetches the host name of the container, because we want to see that the containers are actually separate entities. So we do this to check whether the routes are getting routed to different containers. So let's wait for this. Okay, I speed things up and actually finish building the containers for the server and the front end as well. Now I'm just going to test whether the load balancer works by going to this link. So as you can see, this is actually the response of the container's host name that's giving me the response. So if I were to do refreshes, you can see that it's responding with different containers. So 6.2, I'll go back to 6.2 once again. So this means that all 5 containers are actually talking to me back. So let's just load the front end of 3000. So this is actually the front page that you will see. Then let's just drop some image down. So you can see the client actually loads the image first, and once it receives the response from the backend server, you start rendering the objects here. Then let's just try another cat process after it receives the JSON response. So like I mentioned, there is this minimum confidence level. You could have seen just now that there were red boxes, there were low confidence. Now if I have to raise it up, you'll see that the red boxes are no longer there, and they will only show accurate results of the image. So that is actually the end of our demonstration for the front end. Let's just head back to the back end, And it's also, there's another additional feature about Docker Swarm, is a benefit of it. So if I were to want to increase the containers to more, so let's just see now I have 5 containers. I can easily scale the containers. 50 is too much. Let me try 10. So I have to type scale pro YOLO to 10. You actually run the replications from 5 straight away to 10. So it's very scalable in terms and very easy to configure many replications of the container, which I think is fantastic because you see now there's 10 YOLO servers. So we can actually adjust the number of containers accordingly to our needs. Thank you for listening. Bye bye.
Today we'll be showing you how the application works and how did we go about building this application. So first of all, we will start up the app with docker compose up command. So right now we are able to go to our local host, and which will be where our front end is, which is the React application. So with that, so basically our application have two methods of uploading an image. So first of all, we have the traditional and way of simply selecting from our file explorer, and after clicking on an image, you will receive the object detection. So similarly, we are able to do it for we are able to drag the image in as well. So here we have a demonstration. Yep. So here we have our system architecture with React being the front end and a load balancer using Nginx, our group of servers that Nginx is in charge of, which is the Flask. And this Flask will process the image using YOLO and get back the response, such as the JSON response, such as the positions, the label, the confidence, so that the React front end can overlay using those position points to create those rectangles on our image. So this is actually a reverse proxy pattern where the front end only talks to Nginx and Nginx decide which Flask services to use. So in this case, we are using the list connection, which is here. So Nginx will decide which of the two Flask services to delegate the post request to based on list connection and load balancing. So this list connection method was chosen as it appears to be a fairer choice compared to the default round robin that only allocates load sequentially. So sometimes image sizes and amount of possible image to be detected can vary. So if you just look at this example, it's only one image with one object detection, whereas you have this image where there is multiple 10 20 amount of detection, and these two will have a different response time since this will obviously take longer to process. So as such, instead of blindly following a sequence to distribute load, our load can be distributed based on which server is the least busy at the moment. So without the load balancer and multiple servers, what will happen is in image, right? If you were to upload if you upload this and upload another image, the first one will have to finish before the next one can take place. But if you have load balancing, what will happen is you see that the first Flask will service the first image that was being requested. The second Flask service will then take on the second image that was requested. So this is the power of Nginx, where it can distribute the load instead of just one Flask service handling all of the image requests. So this will obviously lead to better availability, since you do not have to wait for the server to be done, because there is another server on standby. So we have designed the application such that after processing the image and receiving the positions of the object detection, we are only sending back the JSON response to the front end instead of the entire image. So what this does is it helps to reduce the load being passed through the REST API. So as you can see here, we have only our JSON response is being sent to the front end, such as the X and Y, the confidence label, and we have created a function that can take in all of these coordinates, and we will draw the rectangle and overlay over the image. So this will help to reduce the response time, since it's faster to render just these small rectangles instead of having to send the whole image across the network. So each of the components in our architecture was selected with considerations of its performance. So first of all, with React, we chose it because it is one of the best performing front-end framework, as it is designed to be a simple and lightweight JavaScript library. So one of the advantages of React is the fast rendering, which uses virtual DOM through React's memory reconciliation algorithm, as opposed to conventional DOM, which many other framework uses, where it is a tree structured. So small changes at the top layer can create a ripple effect to the in the interface. So with this virtual DOM, we can render front end at a faster rate, which is better in terms of showing users what is being presented on the front end. So we talked about Nginx previously. So yeah, we are using load balancers to help in the increase performance in terms of availability and like failover. So with Flask, we selected Flask as it is a micro web framework written in Python, which coincidentally is what YOLO is also having. So it does not require any tools or libraries to run, and it does not have any database abstraction layer and form validation. So this causes Flask to be very lightweight, which is important, especially in this Docker environment where we have multiple Flask services that is being deployed. So if you have a small size service, it will help. You can have more of them, and it's more scalable, and also reduces overhead. Some of the ways that we optimize Docker is, for example, selecting small size images that can provide the same functionalities as the full size images. So here is our list of our images. So for example, we have a Python, but instead of using the normal Python, we have this image that we picked up online, which is Tiangolo Manhelt G Unicorn, where it is a smaller size. We compared previously where the Python was 969 megabytes, well this is only 921 megabytes. And then like simple things such as Nginx Node, we try to use the Alpine version, which is the smaller one. So as long as there is the library that we need, we don't really need to have the full image, we can just have the lighter weights one, and this will help save our the overall total size of our application. And some of the other things that we do is we run commands on a single line rather than multiple lines. So for example, you have this long line, so instead of doing a run 3 times, so we have run one installation, one git clone, and another pip install, so we instead just concatenate them into a single line. And the reason for doing that is because every run command creates another layer in the Docker, so every layer can be a unnecessary wastage of space. So instead we just shrink them all into one line and run them, where we can reduce the number of layers. So last of all, we also try to minimize the build time. So how do we do that is we will try to structure the application, or I mean the Docker format, such that things that we will not change as frequently will be placed at the top, and things that are changed more frequently will be placed at the bottom, since the Docker will realize that you don't have to change the top layer and you can just proceed to the bottom. Whereas if something that change frequently is at the top, then everything else at the bottom will change, even if they don't have to be everything at the bottom will have to be rebuilt, even though they don't have to be rebuilt.
So hi, this is Team 8 project. Image recognition is easier than ever. Okay, so this is how we will start all of our container. So this is to show that all of our container is running. So now we'll be selecting some images and drag it in. Okay, wait for it to upload. Submit. Okay, so the images are here at the image gallery. So you can click next to view all the images. So when you click on the image, it will show you the confidence level, sorted in descending order. So this is our architecture diagram. We have 2 front end and 5 back end server. They are all load balanced, so that when one of the front end goes down, there's another one to back up for it. So now I'll be showing you all of our container. So now I will queue one of the container, front end 1. Okay, so this is to show you that front end 1 has been queued, and now we only like front end 2. Now we will be refreshing the website, and you will realize that it takes some time to load. That is because NGS does not know that the container is dead. After timeout, NGS will mark it as unavailable and not send any request to it. Now we will show the logs to prove that Nginx is serving the request with the front end 2. Nginx has a rate limit of 5 requests per second. JMeter is configured to send 20 requests, and you will see that Nginx will respond with 503 service temporary unavailable. We will demonstrate the performance of our application by sending about 30 images to the server. You can see from the network that all returned successfully. The entire process took less than 30 seconds. These logs that we are showing now is proving that the requests are being handled by different backend containers. Look at the container name on the left.
Okay, so I hope you have enjoyed the 10 team presentations and hopefully all of us have learned something from there. I'd like to use the last 5 minutes of the time with you to just go through the program and do a very short roundup. So at the very beginning of the program, we talked about what are the learning outcomes that I have. So to distinguish the different factors, requirements, apply the matrices, profile, to identify any bottlenecks, anti-patterns, trade-offs, or recommendations. I really hope that this program, or rather this module, has served well these learning outcomes. We have broken these learning outcomes into the following boxes in blue, where we do the workload identification, performance requirements, performance modeling, performance testing, and the deployment. And recall in the first part we talked about the workload identification. That is really to find out how much load we are really expecting of the system. And from then on, we then talk about how these workload can be so-called that can be measured in our computer system, be it an Android system or be it a web server. So then we talked about how then do we write these requirements. So there's a proper way to write them, and we introduced and we recommended this is the best way, or rather not best way, but this is a way that you can write them in order to make your requirements a lot more complete. And then we also talked about these few technologies here, and the Docker, the Android SQL, the Swagger, Postman, Node. Some of these we talked a bit less, some we talked more in larger detail. But then at the very end, I think there was one thing that I felt, I mean, as what we all are encouraged to do, right? Every time we complete a task like a sprint review, and we have something that's called retrospective. So I would also like to share with you the module retrospective that I might have, and how I might do it differently as we come to the end of the module. So the one thing that I felt I can improve on, and there may be other things, and you're welcome to tell me that, that is that the module might have been taught in a bit too disjoint portions. So for example, we measure all the workload, we do all the requirements, everything, and we use Erlang's formula to find out what is the number of servers that we need. But then again, the number of servers that we need are going to be linked back to how many containers that we need. The number of containers that we need will be linked back to what might be the requirements of the machines that those will be running on, which goes back to the requirements. So one of the things that I felt I should improve on in the next one is how can we merge these two parts together a lot tighter, meaning that how can we, from the time we have the workload estimation, the requirements, how can we plan what should be the right specifications for whatever system, be it Android or be it web server, that we need to be running on. I think in the next time I rewrite the course, that probably will be one thing that I'll be doing. So that is part of my retrospection. I believe there may be more. There will be things that I will expand on in the next one. There will be things that I will cut down on in the next one as well. And you're also at the end of your so-called your actual learning journey in SIT before you go off to IWSP. And in a way, I also strongly urge you all to, at this point of time, and also when you graduate, to do some form of retrospection to really see how you have sort of grown from your first year up to now, and also what are some of the things that moving on you think maybe you might not have done that well in these 3 years, but it's not the end. This is actually the beginning. And in the beginning of your career, as you head up for your IWSP and subsequently your careers, right, what are some of the things that you can circumvent and even do better in order to become a better professional? Yeah. So with this, I'd like to end off the lectures now. Wish you the best for the exam on Monday, And if there's any question, to let me know. This lecture, I think there's one question: will this lecture be tested? The answer is no. So yeah, but I'm telling you at the end, so you have no choice. You have listened to it every day. Anyway, thank you for listening, and all the best for the paper on Monday. Thank you.